Hi there, everybody. We're going to learn a couple of new tests for showing that series are whether series converge or diverge today. The first one's called the p-series test, and we've seen series like this before. You saw them in yesterday's lesson when we used the integral test to figure out whether they converged or not. In class, we looked at 1 over n and 1 over n squared. We saw that 1 over n diverged, excuse me, and 1 over n squared was a convergent series. And again, we used the integral test to find that. Turns out with simple series like this, it's a lot easier to figure out. And it all has to do with that exponent that's on the bottom. So as long as you have 1 over n to some power, we can figure out whether it converges or not really, really easy using this p-series test. And it turns out if that exponent is bigger than 1, then it converges. If the exponent equals 1, that's the case of 1 over n, okay, which we said diverged yesterday. We used the integral test to show that. But if p equals 1, it diverges. And if p is less than 1, it also diverges. So real easy. All you got to do is, as long as we have a series in this form, then all we got to do is look at that exponent to see if it converges or not. So let's take a look here. Now here we've got 1 over root n. So we got a 1 on top. That's what we need. The power on the n here doesn't look like there's a power, but there really is. Square root is to the 1/2 power. So p is 1/2 here. You know what? I'm gonna model what I want you guys to do. We're going to use the p-series test, so I'm going to write that test down. And p is 1/2. This is the condition that you have to check. And 1/2 is less than 1. Therefore, this series, when p is less than 1, it diverges. Therefore, the series diverges. And it's as easy as that. Now, this one doesn't quite look like a p-series. We got a number on the top, but we can easily, since it's just a constant, and that number is there for every term in the series, we can bring it out. And now, without the 4, we've got a p-series. So we're going to use p-series test here. P-series test, write the test down. P for this one is 5/2, and that is greater than 1. So this one converges. As long as that exponent is bigger than 1, it does converge. Now, this last one is a little problematic. Although we can take the 3 on the outside, this n changes for every term in the series. So we can't bring that part outside so that we have a 1 on top, which is what we need. Okay? We also can't get rid of this plus 1 from the series either. We need just n to a power. We can't do it if we've got a plus 1 over here. So for those 2 reasons, this actually, the p-series test doesn't apply here. And in the next video, you'll see a way for us to deal with this. But as long as we can make it 1 over n to a power, all you got to do is look at that power to tell whether it converges or not.